Okay, so here are the notes for the polynomials and exponents section. This is for day 29. And in this, we are going to be talking about exponents and rules of exponents. And this is going to be the final class. The next class is going to be review. And then after that, we are going to be taking the final. All right, so exponential growth. So if you were to take a piece of paper and keep folding it in half, what will happen? Well, one piece of paper will turn into 2 pieces, which would turn into 4 pieces, which would turn into 8 pieces, which would turn into 6 pieces, and so on. So what's happening is every single time you're going to double the number of cuts. So 2 times 2 times 2 times 2. And if we did this 8 times, it would be 2 to the 8th. And that's what we call an exponential expression. So a to some power is equal to that same number of a's. So if I have 8 2's, then it's 2 to the 8th power. All right, so let's write some exponential notations down. So here, so 2 examples. So w times w times w times w would be w to the 4th power, right? And then if I have 5y times 5y times 5y, that means we have 5y to the 3rd power. But you need to be careful because we have to put everything to the 3rd power, so you have to have parentheses. And then we're going to do 5 to the 3rd power is the same as 5 to the 3rd, y to the 3rd. And we can simplify it again because 5 to the 3rd is equal to 125 y to the 3rd power. Okay. So product rule. So this is saying we have this example, a to the 4th times a to the 5th. Well, what does that equal? Well, if I have a to the 4th, that's the same as writing a times a times a times a. And then a to the 5th is times 1, 2, 3, 4, 5. And if you do all those out, then you get a to the 9th power. And basically what this rule is saying here is if you have any number a's times any number a's and you have the same base, we can just add the exponent. So 4 plus 5 is equal to 9. Okay, so that is the same as a to the 4 plus 5. Right out there. Okay, which is 9. So this is our final answer here. All right, so let's try some examples. So b to the 4th times b to the 6th is the same as b to the 4 plus 6, which is b to the 10. Okay, now this next one, notice inside the parentheses, the 2a are exactly the same. So because they have the same base, we can just add our exponents of 3 plus 4, which means my base is 2a, and 3 plus 4 is 7. So 2a to the 7th. Okay, what is my base in number C, or letter C? Well, -2, -2. They have the exact same base. If one was positive and one was negative, then we'd have a slightly different issue, but they're both negative, they're both the same, which means I have a base of -2. I'm going to add the exponents. 5 plus 4 is 9. Okay, so in D, my base is 10, so I have 10 to the 7 plus 11 is 18. Now this one can get a little confusing because I have this 2 and the 3 out front. I'm going to rewrite this because multiplication is commutative. So it says 2 times 3 x to the 3rd times x to the 2nd. And the reason I did this is because this 2 and 3 do not have an exponent. And because they don't have an exponent, we don't need to do anything with them. They're just 2 times 3. So that's the same as 2 times 3 is 6 times x to the 5th power. All right, so moving on, simplify each expression. So what I want you to do is I want you guys to try and do these on your own. I'm going to have this video just lapse for a minute or two, and then I will post the answers after a couple minutes, so try them on your own. All right, so these solutions, so this one would be x to the 9th, and that's because this x is x to the first. There's an imaginary exponent of 1. So 1 plus 5 plus 3 is 9. This one would be 14 x to the 7th. Okay, this one is going to be negative 2 x to the 5th, y to the 3rd. And again, that's because this has an imaginary 1 right there. Okay, this one is going to be 5 x to the 5th, y to the 5th. And I just want to note that it's a positive 5 because I have a negative 5 and this is a negative, and these two negatives turn it into a positive. Okay, so moving on, the next rule is quotient rule, and quotient is a fancy word for divide. So we have a to the 6th divided by a to the 4th, which means I have a times a times a times a times a times a, because I have 6 a's divided by 4 a's, 2, 3, 4. And if you recall, when you have the same thing on top and do on the bottom, they can just cancel, 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 cancel. What am I left with? I am left with a to the 2nd, and what's on the bottom? Nothing, so I'm going to put a 1, which means a to the 2nd over 1, which is the same as a squared. And the reason I'm going to say it's important to put that 1 in the bottom is because if you're left with nothing on the top, which could happen, you have to have the 1 on the top. You can't just get rid of it. All right, so think about, what do you think the rule is for division? Well, how did we get 2? 6 take away 4 is 2. So the rule for division is to take the numerator exponent, subtract the denominator, and you get 2. All right, so let's try some examples. So this one would be x. 10 minus 4 is 6, so it's x to the 6th. I have an a is my base, so a minus 7 is 1. Okay, now the next couple, now we added a couple coefficients. So we're just going to do 63 over 7. What is 63 divided by 7? Well, that's 9. And then I have w to the 8th, w to the 5th, which means I have w to the 3rd. Okay, so the same thing for this one. 32 divided by 8, well, it's negative 32, so it's negative 4. And then I have a to the 2nd, because 4 minus 2 is 2. And b to the 4th, because I have 5 b's on the top and 1 b on the bottom. And then this one, I have just 10 is my base, and then my exponent is 16 minus 6, which is 10. And this one can get confusing because your base is actually a number, but just treat it like a variable. So like if this was x to the 16th over x to the 6th, it would be x to the 10th. So it's basically the same thing. All right. Next one is power rule. So if you have an exponent on the outside of parentheses, everything on the inside is going to get that exponent. So that means that this is going to be x to the 4th times y to the 4th. So I'm just distributing that exponent in. All right, so let's try a couple. So this one would be 2 to the 3rd times x to the 3rd. And we can just simplify a little further because 2 to the 3rd is 8x to the 3rd. Okay, so this one would be negative 3 to the 4th, x to the 4th. And just something to keep in mind is that this negative 3 has to be in parentheses because I have to make sure I put that negative to the 4th power. And 3 to the 4th power is 81, and it's going to be positive because I have an even number of them, x to the 4th power. Okay. Now, we didn't really talk too much about this. I didn't give a rule, but when you have a power to a power, so we have 2 to the 5th, 2 to the 3rd, okay, that means we're going to take these two exponents and multiply. So if you have two exponents that are being raised to each other, the rule is to multiply them. So that's going to be 2 to the 15th because 5 times 3 is 15. This next one would be x to the 12th. And the next one, now I have 2 to the 4th, because can't forget about that too. X to the 3rd to the 4th. Well, 2 to the 4th is 16. And x to the 3rd to the 4th is x to the 12th. And this should be an equal sign. All right. So that's the power rule. Okay, and the power rule is going to work the same for quotient. So if I have x to the 3rd over x over 2 to the 3rd power, that's going to be x to the 3rd over 2 to the 3rd, which is x to the 3rd over 8. Okay, so we're just going to distribute the exponent into the quotient. All right, so let's try these. So 2 to the 3rd to the 4th is 2 to the 4th over 3 to the 4th. which is 16 over 81. And yeah, we could simplify it a little. All right, so now we have m to the third to the fifth would be m to the 15th over n to the fourth to the fifth is n to the 20th. And we can't do anything about simplifying this because we have an m on the top and an n on the bottom, so they are not the same base, which means we're done. Okay, let's try the next one. A to the second on the outside is a to the fourth. B to the third to the second is b to the sixth over c to the 10th, because 5 times 2 is 10. And again, we cannot simplify any further because a, b, and c are all different bases. Okay, this next chart, ignore that page number. This is from a previous class that I taught. These are just the rules all summed up into one chart for your reference. Okay, now the next important rule is the zero exponent. And I'm not going to go into why because it's going to be really difficult to do on the computer, but basically note anything to the 0 power is equal to 1. But you just need to note that it's only things raised to that 0 power. So for example, a 25 to the 0 is just 1. This whole thing is being raised to the 0 power, which means that the answer is just 1. But this answer is not 1 because s to the 0 is 1, but I have 8. 8 is not being raised to 0, so that means it's going to be 8 times 1, which is 8. Okay, so that's where it can get a little bit tricky. And we also have the same thing here. This is negative 7 times 1, because t to the 0 is 1, which is going to be the same as negative 7. All right, so moving on, negative exponents. And negative exponents, this is where it's going to get tricky because we can't work with negative exponents. We have to make negative exponents positive. And the way to make a negative exponent positive is to take this negative exponent and to put it on the opposite of where it is. So right now, this is really a to the negative n over 1. And to make it positive, I'm flipping it. So anytime you want to make a negative exponent positive, you just have to flip its location. So if it says a to the negative 10, to make that positive, that would be 1 over a to the positive 10. So this negative 10 became positive by putting it in the bottom. Okay, so now this one, 2 to the negative fourth, is going to be 1 over 2 to the positive 4. And this one, don't be tricked by this negative, because this negative is not an exponent. We're only looking at this negative here. So this negative is not going to turn positive. The only negative that's going to turn positive is my exponent. 1 over negative 4 has to stay negative 4 because I didn't flip it to the positive 2. Okay. All right, so let's try these examples. So this one, note, this 3 has an exponent of positive 1. So that is not going to change. So that's going to stay on the top. And this w to the negative 4 is going to come on the denominator as a positive. Okay, try the next one. This 10 is a positive, so it's going to come here over x to the positive 5 to make it that negative to a positive. Now this one, do you see how we have parentheses? This whole thing is being raised to the negative. That means that this whole thing has to come to the denominator, and it's going to have a positive exponent. All right, now this negative 5 does not have an exponent, which means that negative 5 is going to stay in the numerator, and only the variable that has the exponent is going to come down with a positive exponent. Okay, and again, these can get a little confusing because some negatives change, some negatives don't, but just know only the negative exponents are going to change. Okay, so now these expressions over here, notice how a lot of the negative exponents are in the denominator. Well, how do you make a negative exponent in the denominator positive? You move it up to the top. So 1 over x to the negative 4 is going to be x to the positive 4. This is going to be 3 to the negative 3 to make positive, 3 to the positive 3. Okay, now, here, this 2 does not have an exponent. That 2 has to stay on the top. It's not changing. See this 3? It's also a positive exponent. There's no exponent with that 3. The only thing the exponent's attached to is the a. So that 3 also has to stay. But this a to the negative 2 is going to come up top because it has a negative exponent. And then this last example, they both have negative exponents, which means they both have to flip. So it's going to be d to the positive 7 over c to the positive 5. So a couple examples. So I have x to the 9th times x to the negative 5. Again, we have to make everything positive. X to the 9th has a positive exponent, so it's going to go on the top. This x to the negative 5 has negative exponent, so I'm going to move it to the bottom. Now the trick with this one is I can simplify further because they have the same base. And think about what was the rule when we were dividing things that have the same base. You have to subtract the exponents. So this is going to be x to the 4th. Okay. Next one. Y to the negative 7. I need to move it to the bottom to make it positive. Y to the negative 3 has to move to the top because we have to switch to make a positive. All right. Now remember, we can simplify this because they have the same base. So the rule is going to be y, I'm going to put this one out because it's a little trickier, 3 minus 7, which is going to be y to the negative 4. But that's not good because that's a negative exponent. So how do we turn that negative exponent positive? We're going to be 1 over y to the positive 4. And there's a couple other ways you could go about doing this one, but that's just one way. All right, and then this last one. So I'm going to, a to the negative 3 is negative. I gotta turn it positive, so I'm going to bring it to the bottom as a positive. A squared, that's positive. That's going to stay positive on the top. Now, a to the negative 5th is on the bottom as a negative, so now I have to move that to the numerator as a positive. Okay, now we got to simplify. Well, a to 2 times a to the 5th, they're on the top together. Let's combine them. What was the rule when we did that? We have to add the exponents. So it's going to be a to the 7th over a to the 3rd. And the rule now for dividing is to subtract. So we have a to the 7 take away 3 is a to the 4th. Okay. And when we have a negative exponent raised to a power, it's going to be the same rule. So we're going to take that negative 3, distribute it in. So it's going to be a to the negative 12 over b to the negative 9. And now we got to turn that positive. So you're going to have b to the positive 9 over a to the positive 12. And we cannot simplify that because they are not the same base. I'm going to try and over here. All right, so b. Going to be x to the negative 20 over y to the positive 8 because I have a negative 2 and a negative 4. Okay, now x to the negative 20 has to come to the bottom as a positive. But no, y to the 8, that's already positive, so that's going to stay. It's going to be just like that. And what do we have to put on top to fill the space? A 1. And these are not the same base, so they are going to stay just the way they are. We cannot do anything about it. Okay, so C, let's distribute. We have r to the negative 8 over 5 to the negative 2. Let's turn everything positive. R to the negative 8 is going to come down here. R to the positive 8. And this is going to become 5 to the positive 2. We can just simplify a little. 5 squared is 25 over r to the 8. All right. Then we have one last problem. So here, we're going to do 3 to the negative 3. T squared to the negative 3 is going to be t to the negative 6. All over s to the 3rd to the negative 3 is s to the negative 9. All right, let's make things positive. 3 to the negative 3 is going to come down here. 3 to the positive 3. T to the negative 6 is also going to come down as a positive 6. And s to the negative 9 is going to come up top as a positive 9. The only thing we could possibly do is say 3 to the 3rd is simplified. So I have s to the 9th over 27 t to the 6. All right. This is the last slide, and these are going to be some complicated ones. If you struggle with these, I don't think that you're going to see anything this hard on the final, but they're just in here for extra practice. So just don't really stress too much about these, as long as you get the ones above. So x to the 5th to the negative 2 is x to the negative 10. X to the 2nd to the 3rd is x to the 6. All over x to the negative 12. Okay, now I'm going to make things positive. So I'm going to, x to the negative 10 is going to come down as a positive. X to the 6 is going to stay on top because it's already positive, and x to the negative 2 is going to come up top. Now I have to simplify. That gives me x to the 8th over x to the 10th, which is the same as 1 over x squared. All right, the next one. So 12 and 16 are both positive exponents. I'm going to leave them just where they are. A to the negative 3 is going to come down as a positive 3. B to the negative 2 is going to come down as a positive 2. A to the negative 2 is going to come up as a positive 2. And B to the third is positive, so that means it's going to stay down here. Okay, so 12 over 16 I can simplify by dividing both by 4. So that gives me 3/4. And now I notice I have 2 A's on the top, 3 A's on the bottom, which means I'm going to be left with 1 A on the bottom because 2 minus 3 is -1. So that means it's why it's A's on the bottom. And then on the bottom, I have B2, B3, which makes B to the 5th. And that's the end of that one. Okay. This last one is extremely tricky. So the first thing that I'm going to do is I'm going to notice this exponent on the outside is a -3. And to make that exponent positive, I have to flip everything and it's going to become a +3. So that means that everything on this bottom is going to come up top, just like you see it. X to the -4, y to the -2, z to the third. And everything on the top is going to come to the bottom. X, y to the -3, z to the -5. Okay, now let's do some simplifying. So now I got to take everything and make it positive. So x to the -4 is going to come down here as a +4. Y to the -2 is going to come down as a +2. Z to the third is already positive. It's going to stay. This x is a positive x, so I'm going to leave it down. Y to the -3 is going to come up top as a positive, and z to the -5 is going to be a positive as a positive. Okay, finish it up. So let's simplify. Z to the third, z to the 5th is z to the 8th. And then I have a y to the third on the top, a y to the square on the bottom is going to give me a y on the bottom. Oh, sorry, a y on the top. Let's erase that. And then I have x to the 4th and x on the bottom, which is going to give me x to the 5th. And now the only thing we have to do is take that exponent of 3 on the outside and distribute it. So z to the 8th to the 3rd is z to the 24th. Then I have y to the 3rd over x to the 15. And that's your final answer. All right, so that is the notes. I'm going to also post a homework assignment for this. So let me know if you have any questions. And remember that your final is going to be the next test. Good luck. Bye.